Alright, so let us look at another situation. Now, let us say you have a box and then you move this box a certain height, h, above the ground. Alright, so the work done due to the force applied is going to equal the force, okay, that is your applied force, times your displacement times the cosine of the angle between the force and the displacement. Here, the cosine of the angle is 0. So you're going to have, here the angle theta is 0. So what you have is going to be cosine 0. Okay? So therefore it's going to be the force applied times the displacement times cosine 0 is 1. So you're going to have the force applied times the displacement. Now, what about the work due to gravity? The work due to gravity. Let's find that out. So before we talk about the work due to gravity, we have to establish our zero line. Okay? Notice that the work due to gravity is the force of gravity times the displacement times the cosine of theta. And the work of gravity can also be what? The negative of the potential energy. Okay? The negative of the potential energy. Alright? So if you pick up the box from the zero line, which I'm going to explain very soon, when you pick up the box from the zero line and then you raise it up a height 3 meters above the ground, if you release the object and probably you have, let's say, an orange, or no, not an orange, let's say you have a breakable plate below and then you release that object from that height, you find out that the object is going to smash the plate, which means that there is stored energy in the box that is causing that kind of situation to happen, or that will cause that kind of situation to happen. So that means that that stored energy is going to be your potential energy. So we can express it to be in this form. So first, let us set up our zero line. So now that we've set up our zero line to be below, which is the initial point before we raised the box to that height, 3 meters, before we lifted the box to that height. Now that we've set up our zero line, we can see that the work due to gravity is going to equal the negative of the potential energy. Okay, so therefore that's going to be what? Negative mg y initial minus y final. Okay, so what do we have? We have our potential energy to be what? Negative what? Mg. What is y initial? Well, y initial is 0 and y final is 3 because we lifted it 3 above the ground. So therefore what we're going to have is negative mg multiplied by negative 3. So what we have is mg3 or 3 mg. So in all, the work done due to gravity is the potential energy, which is equal to mgh. Okay, which is equal to mgh. So the first thing you need to do is just to set up your zero line. Once you've done that, then you should get your answer. So what's going to be the net work? So your net work is going to equal what? Your network should equal your work due to the force applied plus your work due to gravity. That should be your network. Okay, so you add the both of them, and that will be your network. What if there was kinetic energy in this situation? What if we had kinetic energy in this situation? And let's say you lifting the box up, the velocity final was 2 meters per second. So therefore, it means that your network plus work due to gravity is going to equal the change in kinetic energy. Alright, so that's going to be the way it is. Okay, so that's the end.